Welcome back to the second part of graphing exponential functions from section 9.3. Now just as a reminder, this was the graph that we sketched when we had f of x is equal to 2 to the x. This second graph is the graph of g to the x equals 2 to the opposite of x. Now I want to briefly talk about this one a little bit more. There are two ways that you can see this written. One is with the reflection in place. The second way is to remember that this could be rewritten as 2 to the negative 1 raised to the x power. Again, just using an exponent rule to pull those apart. And then writing this as 1/2 raised to the x. So 2 to the opposite of x and 1/2 to the positive x power are the exact same graph. And so you will see these written in both of these ways. So as we generalize the graphing of exponential functions here, we're going to look at both of these methods. So in general, if I have an f of x is equal to b to the x, and our b is greater than 1. Notice in this example I use 2. So for any b greater than 1, you're going to end up having this shape. And with any of these graphs, there's a few things you should be able to tell me. First of all, we're going to go back and pick up something we haven't talked about in a while. What is the domain of this particular graph? Well, remember we talked about the fact that this part of the graph will never touch the x-axis or go below it. So therefore the domain of, well, that's going to be for the range actually, but for the x values, our definition does tell us that any x value can go in here. So our domain is -infinity to infinity using interval notation. Our range, however, deals with the fact that this graph never goes over the x-axis. So our range value is going to be from 0 on up. So our range value is 0 to infinity. So those are a couple of things you should be able to tell me with any graph. Another thing that this graph has is notice that it has only one intercept. And that intercept is a y-intercept. Doesn't cross the x-axis, so there's no x-intercepts. And that y-intercept is 0, 1. Now this is what I will refer to when I'm graphing as the key point. That's an idea we talked about back in chapter 3 that we're going to bring back into play now. So that's the key point for an exponential function. Next, you'll notice that this graph increases from left to right. As I move from the left to the right, the values get larger. And finally, it does have an asymptote. And the asymptote is again a line, and in this case it is a horizontal line. It's the x-axis. So we write it as an equation. The equation of that line is y equals 0. So be careful to always note the asymptote as a line. Now the second one over here is very similar to the first, except in this case we're looking at our graphs being f of x equaling b to the x, where in this case our values are between 0 and 1. So notice that the definition takes into account the rewriting of the graph we had originally done, that it's written in terms of a fraction. So a fraction will always have this reflective property that we see in this graph. Now there's a lot of things that are the same as the previous graph. The domain is still -infinity to infinity. The range is still 0 to infinity. The intercept, or key point as I'm going to call it, is still 0, 1. So again, still the key point. The difference is, though, that this graph is decreasing from left to right. It gets smaller from left to right. So that is the one main thing that is different from the previous graph, is that the first one is increasing, the second one is decreasing. It still has an asymptote, and that asymptote is still going to be y equals 0. Okay, now one thing to note also with these two graphs is that they are one-to-one functions. And so if they are one-to-one functions, they will have inverses. And that's something that we will address at a later date, but it is something that's important to point out at this point in time. So now let's take a look at some examples and look at how we're going to go about graphing those. Now we're going to use the same procedure that we did in section 3 back in chapter 3, and we'll be looking at being able to identify the key points and the asymptotes. And I'm going to have to stop this video here and try again to do the examples on a third one.